All right, welcome back to video number 2 in our series, Writing an Interpreter in NIM. Before we jump back in, there's a couple of things that I wanted to cover from the previous video, a couple of notes and corrections. The first one is that you may recall I was fumbling about, a little bit confused about the idea of a forward declaration when NIM requires that you declare the proc or function before you actually provide the implementation. And I actually found where in the official NIM tutorial it describes this. Surprisingly, in the manual itself, it kind of only covers it in passing. It sort of makes sense because there really isn't a whole lot to it, but I would have preferred that it be treated formally in the actual manual. But in any event, I'll pull up the tutorial documentation to clarify and kind of explain what I learned since the first video and how it impacted the code we wrote last time. So as you can see here, the docs say every variable, procedure, etc. needs to be declared before it can be used. The reason for this is that it is non-trivial to avoid this need in a language that supports metaprogramming as extensively as NIM does. However, this cannot be done for mutually recursive procedures. And here they have this example where two procedures are defined, odd and even, and they're both defined in terms of the other. So odd is if n is 0, false, otherwise if n is equal to 1, or n minus 1 is even. And then even, right, so in other words, odd calls even, and then even is defined similarly. If n is equal to 1, false, otherwise n is equal to 0, or n minus 1 is odd. So now we are now in a bit of a quandary, because if it is the case that every variable, procedure, etc. needs to be declared before it is used, well then even has to be declared before odd, but then at the same time odd needs to be declared before even. The way to resolve this is with a forward declaration. And that's what it explains. Here, odd depends on even and vice versa. Thus, even needs to be introduced to the compiler before it is completely defined. The syntax for such a forward declaration is simple. Just omit the equals and the procedure's body. The assert just adds border conditions and will be covered later in the modules section. Later versions of the language will weaken the requirements for forward declarations. The example also shows that a proc's body can consist of a single expression whose value is then returned implicitly, right? So you'll see here that single expression, there is no return. The return is implicit. The point that matters for us is that we can actually avoid needing to do forward declarations in most cases, so long as we organize and order our variables, procedures, etc. in the right way, right? So you always want to make sure that any procedure, that was the example that we were dealing with in the first video, that the procedures that you reference or use, that they were defined earlier up in the file. And so someone made the point to me that, it's somewhat of a matter of personal preference and people get used to it, whatever. The point is that it's often the case that in a NIM file, you might have the part where you actually check, okay, when is main module, right? Back in here. So we have when is main module, right? Let args equal command line params, etc. That's where you're actually running your program. And so it is not uncommon that that will end up being all the way at the bottom. And that might be a little bit different from what you would experience in Java, for example, where you have some class and then main at the top, and then you have all the methods and whatever else defined later on, because of the fact that in NIM, all of the procedures need to be declared before they can be used, right? It may very well end up being the case that you are going to have your when is main module part all the way at the bottom. But the more important point is the fact that what I hadn't realized in the previous video, again, is that we can avoid the need for forward declarations in most, if not all cases, except for this mutually recursive procedures example that the documentation points to. which is, obviously less common, we can avoid it just by ordering things correctly. And that is, in fact, what you'll see here is that moving all the way to the top of my program here, I managed to get rid of all of the forward declarations, which is nice. And I've did that simply by reordering things. So make sure that anytime there's some procedure that calls another procedure, that the procedure that it calls is defined somewhere earlier up on an earlier line in the file. So that is point number one. Point number two I wanted to make is another correction. If you look here at the book on the right, so you may recall that where we had left off was we had put into place some of the basic structure of our program, which essentially was that we have this when is main module, and then if we were passed a path to a locks source file, we call run file. Otherwise, we call run prompt to start the REPL. And that's the basic structure of this, right? That we have a run file, which calls run. Run for now just takes all of the, splits it by tokens and then echoes them for now. Otherwise, in the case of a run prompt, it will also call run, but it's just reading from standard in, i.e. the REPL. And I believe a mistake that I made in the first video was that I thought the scanner here that the author was making use of was like the built-in, the scanner from Java util scanner. I'm not sure what the actual package was that I thought it was from. And the strange thing is there is in fact a scanner class like that in the standard library in one of the packages. And it even has a scan tokens method, I believe, and which returns a list of type token. And I didn't give the author enough credit because I had assumed that he simply omitted the import, which is a pet peeve of mine. I really can't stand when code samples aren't complete and they're missing imports, which are obviously very important. But here the author didn't do that. Scanner is actually the class that we need to define. So he defined this later on. And so it's just the case that sometimes you need to peek a little bit ahead because he will show these snippets in isolation, even though there are parts of it that depend on code that he is going to define momentarily. In some cases, there may be a page or two between the variables and classes and methods that he is referencing and when he actually defines them. So that was my mistake in the first video. Scanner here is not Java util scanner or wherever that other scanner class is that was already written, wherever I thought that was. This is actually the thing that we are going to be writing. We are going to be implementing a scanner. So that's point number one, was about forward declarations. Point number two is about this scanner class. Another point that I wanted to make is, and we will see this a little bit later, but I wanted to introduce something just at the top here that you'll see in the code here on the left. So I end up having, and we haven't yet introduced this, we'll get into it within the course of the video. I have a bunch of procedures, in some cases functions, but mainly procedures that you will notice all have a formal parameter of S, and there's no type on it. How is it that I'm able to do that, right? So it's all over the place. I have these procedures that take an S. What is S? Well, S is making use of NIM's using statement, which is something that I learned about between the last video and this one. And I'll pull up the documentation real quick to introduce this. What the using statement is it provides syntactic convenience in modules where the same parameter names and types are used over and over. So instead of these three procedures, foo, bar, baz, that all take a C context and node, you can tell the compiler about the convention that a parameter of name C should default to type context, N should default to node, etc. So you can end up having this, which is obviously a lot nicer, kind of easier on the eyes than repeating C context and node over and over again. The using section uses the same indentation-based grouping syntax as a var or let section, and so on. So One important note here, actually, mixing parameters that should use the using declaration with parameters that are explicitly typed is possible and requires a semicolon between them. So that is what I have made use of here in the code. So here's the using statement, and I declare this variable s, and it's var scanner. And now what that means is that in all of these other cases, I can just say s. And I'll also note, why is it that I've said var scanner as opposed to simply, excuse me, hitting the wrong keys here. Why is it that I've said s scanner, var scanner versus just scanner? And the reason for that is that for a procedure that has a formal parameter that you want to be mutable, you have to declare it as var, as a var. So here it needs to be var scanner because, as we'll see, many or most of the procedures that I defined that take as a first parameter the scanner, they actually mutate the scanner, and so it needs to be declared as var scanner. Now, the other thing to note here is, and this is actually a mistake here, which is helpful, this right here would not work. I can't have s using one of the variables declared in the using statement, and then have, as the documentation said, as it put it, I can't then have other parameters that are explicitly typed. The only way that I can do that is, instead of having a comma, right? If I have a comma here, then NIM will be confused and it will think that, okay, S and type are both of type token type, right? Because we know that we can group parameter types in that way, right? Rather than, if you have a procedure that takes 3 strings, A, B, and C, you can just do A, comma, B, comma, C, colon, string. You don't need to type each one individually. But here, in order to ungroup them, what I need to do is put a semicolon here, and now that will work. Whereas I do not have to do it in the case of this advanced procedure, because it only takes the variable that was declared in the using declaration, right? And I don't have any other parameters that are explicitly typed, but in many cases I do. And so in each of those cases, I need to have a semicolon so that it doesn't think that the next explicit type also applies to the S. So in any event, this is kind of, in my mind, a nice thing. And I think we'll find out that we will find that this very much makes sense. It isn't just like a random weird thing. I mean, maybe it is, but the reason why it's so helpful is because it will often end up being the case, I think, we'll learn in NIM, that since we do not have classes and objects like they exist in a language like Java, where you define methods on the class and then it takes, self or this, so past an instance of the class that's always there. What we will end up having is certain objects that we define, like a class, or the equivalent of a class in Java. Let's say for now, they're not exactly the same, but we'll have some object, and then we'll have a bunch of procedures that will act on that type that we've declared. And so exactly that's what we've done here, right? We have all of these things that provide functionality that's meant to work together with a scanner object. And so, since it will not be uncommon to have a ton of these procedures that all take that type as its first parameter, it makes things syntactically a lot nicer and a lot lighter to provide this facility to the user, that you can have this using declaration or using statement in order to make this a lot less repetitive. Okay. And with that out of the way, I believe we are ready to jump back in and resume where we left off in the book. So you will recall that we have here kind of the basic scaffolding or structure of our program that the author lays out. And he hasn't yet showed us what the definition of a scanner is. He's just trying to show us again the basic outline of our program, where run uses a scanner, and takes a little bit of a detour here to make the point that we do want to have some ability to report errors to the user. It wouldn't be great if there are syntactical errors that make it impossible to interpret the locks code provided by the user and then not report any sort of error, right? So we need some ability to just print to notify the user that there's some, something is malformed in their code. There's some syntactical error that means that it's an invalid locks program. And so he has here just these two simple methods, one of which calls the other. So error takes the line, a message, and then it calls report, which takes the line number, a string of where that happened, which we'll see exactly how he's using that, and then a message string. And then he just prints it to standard error, line, error, message. And then he also sets this variable had error to true, and he will explain what that is. He says here that, where is it? The primary reason we're sticking this error reporting function in the main locks class is because of that had error field, right? So in the context of his Java program, he just has this locks class as the top level sort of container of this program, this interpreter that he's writing. And then these exist in there, right? So in other words, these don't exist within the scanner class, which we'll see how that's defined shortly. This actually exists at a higher level up in the locks class, right? Which he shows here, public class locks. And then there's this static Boolean field had error equals false. And that is so that we don't try to execute code that has a known error, right? We need to be able to track that if the report error method was called, we need to know that throughout the rest of the program so that we don't proceed to try to interpret the remaining program when we already know that there's an error, which is why he will later on, after he calls run, if through the course of run, at some point an error is reported, then if had error is true, then he'll exit with exit code 65. I believe the author explains above that he picked the exit codes based on what he saw in like the standard C header file because it was the closest thing resembling a convention for exit codes that he had seen. And I end up just following that example. And then he makes the point that in the case of the REPL, right, when we do run prompt, if we call run and that ends up resulting in an error, unlike here where we exit, in the case of the REPL, we want to set had error to false, right? Because obviously in a REPL, you should be able to enter code that is incorrect, press enter, see the error, but then proceed. We don't want to kill the entire program. Whereas in the case where you provide a source file, obviously you're just done, right? You've called the program, provided a source file, something about it is syntactically incorrect, then you need to fail and report that error, and that just ends the interpreting of the program. So we will see, so how did I go ahead and implement this in my case? So we'll start with the, report procedure, which I have right over here. So you'll see, just like the Java case, I followed it pretty closely. Takes a line, where, and message. Again, you'll see there that we make use of the ability to group variables. So I don't need to have where string, message string. I can do that, but since I don't need to, I'm not going to. I can just have where, comma, message. These are both string. And then what I do is I get a handle to standard error, right? Like just like in the Java example, he does system.error.println instead of system.out.println. So instead of system out, it's instead of standard out, it's standard error. And then I call writeLine and pass in the same concatenated string that he does in his example. And standard error, I believe this actually comes from the system module, which I believe is imported implicitly. So I can import system, but it appears that every NIM program just has this. So I don't need to actually do that. But that's how I am able to reference standard error, if you're wondering where that's coming from. And then I hewed pretty closely to the to his example again, where, as he explained, he had this class locks, and that's where he put had error. In my case, I just put it also at the top level, right? So I don't have any like class container like he has in Java. I just have this, nim source file that I'm in. I don't know yet if this is the best way to do this or if there's some other way to organize things, but keeping it really simple for now. I have this had error equals false in this, in this var section here. And so that's where I set had error. And then the other method that I have, I believe is, right, we have it here. So error calls report. This is where you'll see, by the way, what we discussed before about forward declarations. In the Java example, he defines error above report. But since error calls report, and in NIM everything needs to be declared before it is used, that sort of imposed this constraint that I had to define error afterwards, because error calls report. So I could not, I could not define this as in the following way. I could not do, I'm really fumbling around here with Vim. I have my microphone kind of in my way, and it makes it a little bit hard to to do this. But the point is, if I move this up here, right, and I tried to use this, we'll see I get this error, right? The nim LSP reports this to me directly here in NeoVim, which is nice, that I am attempting to call a routine report, which is unknown, right? That's an undeclared identifier, so I can't do that, and so that is why I have to, in order to avoid the need for a forward declaration, I define report before error, since error calls report. Okay, and also wanted to show how in the, just as he did in his example, in the case of run prompt, right? So when we run a source file, if had error, then I follow the same example. I follow his lead with, I just exit with exit code 65. Whereas in the case of the REPL, we read line by line, but then if running that individual line resulted in an error, I just set had error to false, right? Because we do want to be able to proceed in the REPL, even if a line had been submitted by the user that has some sort of syntactic error in it and we can't proceed. We just want to report the error and then continue. So that's what I think is relatively straightforward conversion from Java over to NIM. Now he starts to get into really some of the meat of how an interpreter works and some of the main concepts. So we'll just jump right in. Lexemes and tokens. Here's a line of locks code. var language equals locks. Again, you'll note that this sort of toy, small, relatively contained language that he is inventing for the purposes of this book is very much a C-style language. This is probably valid JavaScript. This is probably valid Java these days with the new var keyword that Java has. Used to be this would have to be string language equals locks, but I believe I don't know much JavaScript. I believe that would be valid JavaScript. It's definitely valid Java these days. So nothing kind of surprising here. This is a valid statement in locks, the language that we're writing an interpreter for. And so he explains var is the keyword for declaring a variable. That 3-character sequence var means something. But if we yank 3 letters out of the middle of the word language, like GUA, that doesn't mean anything on their own. That's what lexical analysis is about. Our job is to scan through the list of characters and group them together into the smallest sequences that still represent something. Each of these blobs of characters is called a lexeme, right? So a lexeme is the smallest lexical unit in our language. So in that example line of code, var language equals locks, he breaks this up into its constituent lexemes, and he draws a rectangle around them. So var is a lexeme, language equals locks, and the semicolon. The lexemes are only the raw substrings of the source code. However, in the process of grouping character sequences into lexemes, we also stumble upon some other useful information. When we take the Lexeme and bundle it together with that other data, the result is a token. Okay. I believe the point that he is trying to make here, and I think he clarifies this in just a moment, but it's the idea that our job is not just to say, okay, yes, we recognize that this is an individual lexeme, but the lexemes have different meanings. They convey some sort of a meaning, which has a consequence insofar as the rest of the interpreter or the parsing of the source code goes, right? So, for example, he says keywords are part of the shape of the language's grammar. So the parser often has code like, if the next token is while, then do, etc. Right? So this is where he's introducing that there's a distinction between, it's one thing to identify a lexeme, but when we bundle it together with other data, that helps to convey its meaning as far as the rest of the syntax is concerned, that we call a token. So a lexeme is just like the raw individual smallest lexical unit in our language. When you identify the lexeme and then you pair it with this other data, that gives us a sense of what kind of further higher order meaning does it have, that is a token. That's what we call a token, okay? And like he says, right, so if the next token is while, then do, that's just an example. That means the parser wants to know not just that it has a lexeme for some identifier, but it has a reserved word and which keyword it is, right? Which is just one example of a type of token, as we'll see shortly. The parser could categorize tokens from the raw lexeme by comparing the strings, but that's kind of slow and ugly. Instead, at the point that we recognize a lexeme, we also remember which kind of lexeme it represents. We have a different type for each keyword, operator, bit of punctuation, and literal type. And so he implements this in Java very straightforwardly as an enum, right? He declares this enum token type, and he then goes ahead and lists, I don't know if this is exhaustive ultimately or if there ends up being a lot more tokens, but for now it's left paren, right paren, left brace, right? A plus, semicolon, bang, bang equal, equal, equal. Then he has literals, identifier, string, number, and then these reserved keywords, and, class, else, false, and so on. Okay? And so how do we implement that in NIM? Well, we do it in a pretty straightforward way. So what we have is we declare, similarly, we begin a type section. Okay, in enum we have a type section where we can put all of our type declarations. And you'll see with the indentation here, right? We start the type section. We then declare a token type, which is us trying to implement what he did in Java. We also get into a literal and then a token and a scanner. We will look at that shortly. The point to focus on for now is just this token type. And this is the syntax, right? So you begin the type section. You then give the name of the type. You say it's equal to what? Is it an object? Is it an enum? What is it? In our case, it's an enum. So NIM does have this first class enums, as you would expect any language these days to have. And then it's pretty similar to the Java program, right? Left paren, we just go through all of them. We have identifiers. In some cases, I use these backticks. And I did this not actually knowing before I did it that this was valid in NIM, but other languages do have this where and, for example, or else or false, these are reserved keywords. Maybe in the case of false and else it wouldn't be because they're all uppercase, but in any event, I believe that these will clash with because they're reserved keywords. Actually, looks like not. But in any event, if they were, I can get around that problem by putting a backtick. I think I still want to do that because I want it to be clear just to me that I'm trying to reference my token type as opposed to the built-in one. Even though, again, you could argue that, well, false is actually all lowercase, excuse me, and the same with else. Maybe we'll return to that, but I'm just explaining that the reason I have the backticks is for cases where the words truly are a reserved keyword and wouldn't be a valid identifier, you can surround it in backticks to kind of get around that problem.